So welcome again to everyone, and thank you for coming to this is the Policy Speaker Series from NASA's Carbon Research Program, also known as the Carbon Monitoring System. Today's talk is titled Tree Planting Drone Technology for Global Scale Ecosystem Restoration. To the speaker, I would like to welcome Lauren Fletcher. He's the CEO and the founder of the company BioCarbon Engineering. He holds a PhD in physics from the University of Oxford and a master's in civil and environmental engineering from Stanford University. And he worked 20 years for NASA, and now he's heading his company that is based in Oxford, England. The company provides integrated data and planting solutions for large-scale ecosystem.
Is your
Can you hear me now? Can you hear me now?
Go ahead and try. All I can hear is moving.
Can you hear me now?
Yes, that's good.
Okay, perfect. Thank you. So the company BioCarbon Engineering, they use drones to plant trees and look for solutions for large-scale ecosystem projects. The company initiated operation just last year, and they have already planted about 250 hectares of land in England, Australia, and Myanmar. This last one partnering with Worldview International Foundation to restore and regenerate the degraded mangrove ecosystems in Myanmar. Just this past week, Lauren was in Canada meeting with the Canadian Forest Service and discussing ways in which drone technology could be used to replant forests in a cheaper and faster way. We invited Lauren here to gather to present and discuss the potential of this technology to scale up ecosystem restoration projects around the world, as well as identify potential collaboration between his company and NASA carbon scientists. So we'll have some time for questions and discussion at the end of his presentation. So I'll let you now with Lauren.
I have a microphone here, so I'm good with that one. Hi, everybody. And for those of you who are online, if I start to drop out, it's because I'm not close enough to the microphone, so just let us know, and I will make sure that you can hear us. My assumption is that we've shared the screen so that everybody online can actually see that. So why don't I start with just a little bit of my background. I won't quite go all the way back to the dinosaurs, but I will start with always being sort of environmentally active, born on the West Coast in the Sierra Nevada mountains, so always having that deep connection to the environment there. And then when I graduated, I did indeed go to work as an undergraduate. I was an undergraduate intern at Johnson Space Center, so working in manned space program, which was absolutely fascinating, but it didn't take too long for me to realize once I graduated full-time that hot and flat Houston was just not me. So I transferred to Ames Research Center in California and switched over to non-human life sciences research programs. So shuttle Mir station, Soyuz programs, flying mostly biological research instruments. We'd pack that up with plants or rodents or insects or fish. And that...
Sorry to interrupt.
Sure.
But you're going to need to stand closer. They don't have that place very well. You may have to change where you stand because this is, as soon as you move away.
How about, does this help? Can you hear me at this point?
Yes.
Okay, good. So I tell you what, I'll just hold the microphone for you guys in my hand as well, and that's no problem. So yeah, no worries. If I drop out again, just please feel free to interrupt. So so that was really that first opportunity for getting the intersection of engineering and biology. So I'm an engineer originally by training, but working in biological sciences. And so that is an important place to be, is really to understand, far often the way the NASA programs work is that you have a call for science, and the scientists write their science requirements, and the engineers get their hands on that, and they turn that into engineering requirements, and then that gets sent out to a contractor that comes back with an instrument, and the scientists take one look at that and they say, well, what's that supposed to do? And the engineers say, well, this is what your requirements were. And the scientists said, no, but every scientist knows that this requirement means this. And so there's always some unintended assumptions and a lack of translation. So as a result of that, I actually went down to South America and was studying desert ecosystems as part of Mars analogs. And so retrained myself from scratch, just reading books and papers on environmental microbiology, learning molecular methods, so that I felt that I could be a better engineer because I actually understood the sciences. And so that was a key transition point for me to start to work in this direction. And then as part of that, I went to Stanford and took a degree in civil environmental engineering, close enough to the sciences that I wanted, but an engineering degree because sadly engineers get paid more than scientists, we all know that. While I was there, I took coursework on climate change with Stephen Schneider and Terry Root, and I studied just that small slice of climate change and deforestation. And so then that same year, which was 2009, he took a group of us to Copenhagen to COP15. And that year there was a big theme was deforestation, global deforestation. So they had artwork and exhibits and films, and they were really documenting what was going on a global scale. And so between the coursework and my study and what was going on, that really finally cemented that emotional connection to the issue for me. And you know, for those of us who are, and certainly those of you who are working in ecosystem issues, you're close to it now. But for the rest of the world, and especially those that live in urban centers, it's very easy to get disconnected from the issue. You know, everybody says cutting down trees is bad on a large scale, don't do that. But when you have to get milk or diapers or pay that car bill, you know, it's very easy to get disconnected and say, don't do that, but I got to do these other things. So for me, this made this nice emotional connection to the issue. And so I really understood at that point what was really going on and the extent of it and why forests were coming down so fast. But I was puzzled at why is it so hard to put them together. So like any good graduate student at that point, I spent 15 minutes looking on Google and realized from a search on forestry equipment that what you got was a lot of images of really heavy industrialized equipment from the biggest name manufacturers that's really good at one thing, squeezing every penny out of that resource you can get. But if you turned around and said, well, no, what I really meant was reforestation equipment, what you got was a whole load of pictures of people with a bag of saplings on their shoulders. And that was effectively as automated as the technology got at that point. So I said, well, hell, I work for NASA, like everybody else in this room. I go, we got robotics, we got AI, we got remote sensing, and drones are coming along. And there's got to be a way that we can combine these emerging technologies to create an automated solution that allows us to break the ever-present triangle of better, cheaper, faster, because you can actually do that. When you have a disruptive technology, you can reset that bar to a higher level that allows you to do things that are more effective at a higher rate and at a lower cost. 2009, drones weren't quite good enough in terms of just the base technology, and so I was waiting for a few more years. By the time 2013 rolled along, you had motors, motor controllers, flight controllers that were at a base level good enough on a commercially available level where I felt that I could build a drone, wrap the rest of the solution that I would design around that, and it would only get better from there. So that took me up to 2013, and I was already in my doctoral program at Oxford. And if you ever think that you want to start a company while you're doing a doctorate, I recommend that you do not do that. I also recommend that you do that because good ideas and good opportunities come along when they come along, and you just can't say no to good opportunities. One of my biggest failings and one of my biggest opportunities is I don't know how to say no to anything, and so there you are. So let's do a thought experiment for a moment. We're going to switch into the topic. Imagine for a moment that we can hit a scale of reforestation globally that really makes a difference. And let's think about it from the perspective of we're going to go out and we're going to plant 500 billion trees. Now, when we get to that kind of a scale and that kind of a level, the knock-on impacts are significant. When we plant 500 billion trees, we restore global ecosystems. We protect and expand biodiversity. When we plant 500 billion trees, we restart those soil cycles, we restart the hydrological cycles, recharging aquifers, we increase downstream agricultural productivity, we create materials that local populations can use for secondary product materials and wealth creation. When we plant 500 billion trees, we sequester enough natural CO2 that we can actually have a significant impact on working towards the goal of reducing the amount of atmospheric carbon. So these are the things that we can do when we really think at that scale. And so governments have recognized this. And even though if you take a look at the Nature paper that came out last year, which was documenting the number of trees that should be around the world and the number of trees that have been lost from both anthropogenic and natural causes. There's effectively a net loss of 2 billion hectares, and a rough calculation would be about 2 trillion trees. Now, when you combine that with the $50 billion roughly that's already spent around the world for reforestation activities, and even with that spend, there is a net negative loss. So governments are wanting to step up the plate to do large-scale ecosystem restoration through New York Declaration on Forests, the Bond Challenge, the Africa 100, the 2020 Initiative. You're looking at commitments in the 350 million hectare range and larger. But if you're already a net negative every year, and you're really trying to get to a 2 trillion tree range, how are you ever going to overcome that problem when the state of the art is effectively this? Now, it's not to say that this type of technology and this type of approach isn't an approach that you want to continue to maintain as part of your tool set. It's just that this really limits you. It's physically dangerous. Now, to give you a couple of examples of that, in the Canadian forestry industry, which is, I think, one of the best in the world in terms of the scale and their access, their effectiveness, they've got a 25% annual injury rate in tree planters. 25%. You name another industry around the world in a industrialized country that is willing to accept a 25% injury rate and thinks that's okay. So there's a problem. Queensland, Australia is one of my other favorite examples where they cannot get a single tree planter, not one. And your first response would be like, well, maybe that's because Australia is pretty well paid and it's hard to get people to want to do this job, and that is true. But in Queensland, it's because there's 12-foot crocodiles who think tree planters are tasty, and they just don't want to go there. Who knew? And so you start to take a look at issues on labor, even in markets like Thailand, Indonesia, Malaysia. It's hard to get people, even in those labor markets, to want to go out and do this kind of work. It's really hard labor. It's time consuming. It conflicts with crop planting seasons. It conflicts in Muslim countries with Ramadan. And so you can find, you effectively don't have enough labor to do the job that we want to do. So how do we think about tools that enable these populations of tree planters to be more effective at what they do at a larger scale, more effectiveness? So that's where we came in, where we take a look at a typical ecosystem restoration project where if you look at above the line, the first step is really the rich data sets that we're able to collect now in ways that we were not able to collect before, at certainly higher resolutions than we could do before, where you have that full cycle of planning. You collect the data, you analyze the data, and then you can plan that. And this is a really important step, is how do you actually do the work more effectively? And then once you have that plan, then you can get into the intervention. So think of it as kind of like almost going to a doctor. So ecosystem health services. If you go to a doctor, the first thing that they're going to do is they're going to do an exam, and they're going to take a whole lot of data. They're going to analyze that data, and they're going to make a determination on what sorts of issues you might have. And then they're going to make an intervention plan from that point on. From the intervention plan can include the land preparation, it can include planting, and in this case, you consider this to be an agnostic diagnosis in terms of the intervention. Do you use hand planters as the right solution for that specific project? Do you use ground mechanized equipment? Do you use large-scale, long-range aerial aircraft systems, or do you use drones as a new solution that provides a new tool and a new way to think about it? And then, of course, the long-term monitoring and maintenance is a really critical component to that, to make sure that your outcomes are actually doing what you think they're going to do, which then you go back later on and you reanalyze your diagnostics and you make sure that your original algorithms gave you the right information. And if it didn't, then you go back and you check those algorithms, and you can update those as you go. So for our portion of the intervention, we start with satellite data sets, and it's pretty typical. Think of that if you're going to be, let's say the state of Pará in Brazil has a mandate from the Brazilian government to restore 3 million hectares. Well, which 3 million hectares were you thinking about? Because Pará is a lot bigger than that. And so the satellite data sets, even at 3 to 5 meter resolution, allow you to have a cheap set of data that you can take a look at what's been deforested, what areas are urban areas, what areas have other infrastructure, and then really focus down in where are those 3 million hectare type projects, the smaller scale projects that you want to do. And when you get focus in on a specific area, that's where you come in with the drone data, and the drone data allows you to get down to 3 to 5 centimeter resolution and take a look at topology or drainage, swales, soils, debris, in order to really figure out exactly where you're going to place each individual species. You also take into account the ecology. From the satellite data, you can take a look at tree crown analysis to try to figure out what species are in the area. However, if you got an area that's completely wiped out, there's no natural ecosystem, then you have to make harder decisions on determining what species are natural, or at least what species are appropriate. And then certainly when you're taking a look at climate change shifts, do you want to shift to a different species that has a different tolerance in its temperature range than what you would typically have had naturally. So there's ways you can start to think about it, because the technology that we have allows you to plant in multiple species simultaneously. And we do talk a lot about trees, but the reality is that when you're rebuilding an ecosystem, it's more than trees. It's the canopy, it's the mid-canopy, it's the bushes, it's the ground cover and grasses, and it's the soil ecology. And if you don't consider all of that in your analysis of how you're going to rebuild that ecosystem, then you're not really doing ecosystem restoration. You're doing monoculture. And so from our perspective, certainly the big goal, the 350 million hectare challenge, is rebuilding ecosystems, not rebuilding plantations. Although plantations is a viable client, and so we can't tell them that we're not interested. It's just that ecosystem restoration is what we really want to go after. So to give you a basic idea how the system works with a really great animation, again, we start with that satellite data set, and then when we determine an area, we're using off-the-shelf technology right now. It is honestly like commercial work, and so it's not as sophisticated as the data sets that you're getting, and this is one of the things we want to talk about. But on the other hand, this system, which is SenseFly, is really easy to use. We can use that to take a look at calculating and determining a planting area. And with that, we load that into our planting drones. Now, the planting drones carry seed capsules. So we're planting seeds. We're not planting saplings. That's a big difference. The drones themselves carry right now 400. We're building a bigger storage unit that will allow 1,000 per run. And then we load the planting map and we load the pods into the drone. The pilots, they're fully automated now, so the pilots only have to press a button. The drones launch themselves, they follow the pattern, they're flying at about 10 feet off the ground, and they fire those capsules into the ground with pressurized air. And then it lands itself afterwards. Now, the capsules themselves, they break down with moisture, so they're fully biodegradable. And then once you get them into the ground, then that allows that seed to start to germinate and grow and get into early growth. And we'll go into more details on that. So why seeds? Well, seeds because they are small, and you can carry a lot of them at once, as opposed to saplings, which is not manageable with the type of technology that we have. So think about our technology as a new tool. It supplements what's already there, and you use it when it's the right tool for the right job. And it's not always going to be the right tool, and that's okay. But as a restoration manager, you need to have better tools that give you better data to make better decisions, and better actuation tools that allow you to do the job at a larger scale in order to meet what your objectives are of that specific project. So the seeds are an easy piece to encapsulate. We are limited right now in terms of the size. So our capsules are 1 inch in diameter. The inner diameter of the area open for the seed is 16 to 18 millimeters. So effectively, the largest size seed we can carry right now is about an acorn. Anything bigger than that is beyond what we can do. But then we can do things like carry multiple seeds in the pod of that same species, or you can carry nitrogen fixators next to it, whether it's another species or if it is microbiology, so mycorrhizal fungi, or you can put in soil matrix, or you can put in absorbents. Pardon me just a second. So there's all sorts of things that we can pack into the smart pod, including we can vary the components of the pods themselves, with nutrients in order to tune it out to a specific environment. Oh, you guys can actually see this one. Okay, so in the restoration, this is a typical restoration framework, right? So these are the sort of decision tools that we use in order to make those first step. Obviously, the very first thing is you take a look at that environment that you're going to. You want to know, what is the quality of the soil? What is the type of the environmental conditions? How hot is it? How much rain do you get? And then you use that as your first step of whether or not this is the right technology. If we get to too degraded of soils, like basically sand, we're probably not the right solution for that. And so we don't know exactly where that lower end limit is, but we have to take into consideration what are the actual conditions of the environment before we even make that next step, which is determining what is going to be the type of species that you're going to put into that area. And so even then, once you've determined what the species are, you have to take a look at where are you collecting those seeds from. That's a really important point. Not every place has seed banks around the world, and in fact, as much as seed collection is not core to our business, it's a critical path component for us to actually doing the work. So we're finding that, like in Myanmar, we work with local communities to get them to collect the seeds for us and to store them, and then we do assembly locally of the seed pods, and then we can plant from there. So this is part of the overall problem, is understanding not just what do you want to plant, but where are you going to actually get that material from, and how does it need to be prepared. Taking a look at the next one would be things like, what sorts of seed preparation do you have to do? Do you have to do dormancy breaking? Do you have to do scarification, whether it's chemical or physical? There's all these things that we take into account as we're preparing those seed pods. Then in the planting side, in facilitating the early growth, we can do things like include repellents in there. We can take a look at, well, the seed pods themselves actually provide a certain amount of protection from local predators. So the rodents don't like it. It's not tasty, so they leave it alone. And we've found gnaw marks on them in places that we planted, and they just leave them alone at that point, which means is that when you have enough moisture to break down the seed pod, it leaves that seed there. It's already germinating at that point, which means you are beating that first part of the early germination and growth. And then finally, you have to take a look at the post-planting monitoring and maintenance. You need to go in and determine whether or not your project requires, the objectives of your project requires that you do post-planting maintenance work. Do you need to go in and cut back vegetation? Do you need to do thinning? Do you need to put in nutrients? Do you need to put in other protection from other types of predators? If you want to get your yields to 90% like you would typically have in forestry, then you will have to do those same exact steps with the trees that we plant versus what you would plant from saplings transferred from a nursery. It's effectively one-to-one. Our objective is to take the nursery step, and instead of growing everything in a nursery, is you're moving the nursery to the field. We provide enough of the materials that you need in order to get that seed into the soil, germinating and growing, and then that shortcuts that nursery step. Huh?
We had an issue online.
All right. So we have a short issue online. We are correcting. They're not getting the slides.
Yes.
Not being shared. Okay, well, the good news is, for those of you who are online, is that you haven't missed the videos, which is all the good stuff, and I promise we'll get to the videos. Let's see, where are we? Right, so in the seed pods, we have to take a look at, the seeds, we have to take a look at the quality of the seeds. We have to do all the additional steps in order to ensure that those seeds are going to get to germination and early growth. And then anything else that we need to include, like repellents. So that's a typical step. So when we do a project selection with our partners, when we determine what species we're going to plant and in that environment, we actually get copies of those seeds. We get samples of those seeds, and we have them, they send them to us in England. We have growth chambers there because the first really critical step is making sure that the seeds that we're going to plant have biocompatibility with those pods. So before we go out into the field and do any sort of planting work, we get samples into our labs and we run a full biocompatibility test. We make sure that all of our seed preparation methods are working, so that when we get to the field, we already have confidence that things are going to work the way they should work, and that after that point, then it's local environmental conditions that we don't necessarily control, but need to understand a lot better in order to make sure that we get that next step also optimized and growing. The seed pods themselves are a biodegradable plastic. They completely degrade in moisture. So if I were to put one of these into a glass of water, they would dissolve in about an hour. In Myanmar, in our projects in mangroves, we're planting into nice wet mud soil, dissolved in less than 24 hours. We checked 24 hours later, so all I can tell you is that it was less than 24 hours, but I don't know if it was an hour or if it was 24 hours. But point being is that it breaks down very quickly. If there's not enough moisture, it takes a lot longer for that to break down, and so we do have limits on the type of environments, back to poor degraded soils, environments that are very low in water, moisture availability. These are things that are really at that lower end of what we can do. We're working on different options that allow us to increase our range of environments we can plant in. But for now, these are sorts of things that we have to consider very carefully when we're selecting a project to make sure that we're aligned with the environment and with the species. Otherwise, it doesn't make any sense for us to go out there, because you won't get the result that you need. So now the drones themselves. You can see a picture of one of them right here. Above the deck, you see the propellers, and that is pretty much all off-the-shelf technology. So we buy the motors, we buy the motor controllers, we buy the flight controllers from everywhere else. We have a custom frame that we have built for us by a manufacturer in England. And then everything below that below the deck is ours. So you've got the planting mechanism, and then you got the feeder mechanism, so that's where all the seed pods go in. And then we have a pressurized tank right here, and that is what we use to pressurize the system. So it is pressurized air. It fires into the ground, well, we don't like to use military language, but it might be something not dissimilar to a gun. With pressurized air. So an airsoft pistol, and then that gives us enough force to be able to penetrate in most soils, but we do have, again, a limit on the hardness of the soil. So if it's a baked clay, our pods are going to bounce right off of it. So then we have to pay attention very carefully of the timing of the year to make sure that if it is going to be a clay environment, that it's moist enough and loose enough that we can actually fire into that. And so again, it's a different way to think about restoration activities, because the technology is new, and we are learning ourselves just as much as everybody else on how the technology is best suited and for which environments. And one of the most important things that we're going to be doing is really getting this technology into the hands of people who are doing the work, because we have a good idea of how we think it should be rolled out, but the reality is that it's the people in the field who are going to use it in ways that we just didn't even think of, and they're going to come back to us and they say, well, Lauren, that idea was really stupid, but here, let me show you how it actually works well. And so that's going to be the most important thing for us, is to really get it rolled out and get other people using it, because they're going to be the ones that are best suited to make it work the way it needs to work. To give you an idea of the size, it's about 1 meter across, so 3 feet. It's currently, this version is 13 kilos total, so that works out to be about 30-something pounds. So it's quite a big system, full commercial. It's got 8 motors, so it's an X-wing, but it's got motors top and bottom, so we can suffer a motor dropout if we need to, and we can still land it safely. That's not an issue. Now, the precision payload, we've got 2 payload delivery systems. The one that I've been talking about has been our precision pod system. It's firing at 2 pods per second, 120 a minute. And this is a really important part of the scaling factor. So it's almost like a little machine gun sort of thing. So we're carrying, effectively we can, in practice we can get up to 3,300 pods an hour. We're carrying 1,000 at a time, which means we have to change it out, at least 3 times an hour. But we're going so fast that we're actually running through the pods in about 8 to 10 minutes, even at 1,000, at 120 a minute. So that means battery power, which our drones have about 50 minutes of flight time fully loaded. We don't go through the batteries at all. We're going through the load of pods a lot quicker than we are. So that first part is 120 a minute, but the second part is going to be that we're implementing swarm technology on this. So we're going to be able to operate upwards of 10 drones simultaneously from 2 pilots who are operating just a base station. Now, that's where the real power play comes in. Because at that point, with 120 a minute per drone, and upwards of 10 drones, and then operating for a day, what that means is that 2 operators would have the capacity for planting nearly 400,000 of these a day. 400 teams around the world a year would get you to 10 billion a year. And these are the scales that make the difference on the deficit and allow us to start attacking the real problem. And you have to think about it in these scales, because if you don't think about it in these scales, because at one point when I first started this, I said we're going to do 1 billion trees a year, and everybody's like going, wow, that's so ambitious. And then we got to WRI and they say, wow, that's a really great number, but that's not nearly ambitious enough. You need to be thinking 100 billion a year, because if you're not thinking 100 billion a year, then you're just not thinking big enough. And then I had to go sit in a corner with a beer for a while and cry. Because here I thought I was being all ambitious, and it turns out I wasn't nearly ambitious enough. Yeah.
Just for scale, you guys are firing 1,000 per hectare or something like that?
Well, it depends on the project, but for rough numbers, 1,000 per hectare.
So 400 hectares a day for your team of 2 operators, 10 drones?
Yeah.
Okay.
Yeah, just to put it in terms of scale, exactly right. Yeah. So that's that one. Now, the other one that is interesting is a system that we built for direct seeding. So again, a tool that's common use right now is aerial direct seeding, but the issue is that getting helicopters in a lot of areas in the world is impossible, or getting large aircraft is really expensive. So we built this system right here, which is a 10 kilogram payload. So it's enough to run a few hectares at a time. So it's a great start. It allows us to do smaller scale projects, and this is another tool. We are working on a different delivery system right now that will give us 150 kilos of up mass on the payload, and that'll be coming out in about the next 6 months. And that will really change sort of the dynamics of that long range, larger area seed distribution, if that is the solution that people are looking for. And it's certainly really great for grasses on slopes that have been burned out if you want to stabilize soil types, or if you've got regreening projects where you want to do 30 or 40 species at a time, but you're not necessarily worried about getting high yields. You're willing to accept low yields and associated with direct seeding. This is a super low cost system. The new one will be effectively about 5% of the cost of helicopter delivery. So not counting the cost of the seed. So these are the types of new innovations that are coming out that are going to really change how you think about a project. And when you think of, we're going to get to it, but when you think about projects, you have to think about this in 2 ways. First is, how does this scale allow me to do a job that I didn't think I could do before? And then, how does it change the cost dynamics? And I'm going to get to that point. So let's go into case studies, because this is where all the cool videos are. This is what you guys have been waiting for. I appreciate you listening to me talk so far. Let's get on to the videos. So mangroves, yes, we've been working in mangroves in Myanmar. That earlier picture that I showed, the difficulties, that was actually from a mangrove in Myanmar. Typical mangrove restoration, when you're getting out of the mud flats with the tide out, you're knee deep in mud. With the tide in, you could be waist deep in water. And that makes it significantly difficult to do any sorts of planting work. So we beat that by not having anybody out in those mud flats. Now, we have a proposed add-on project with the work that we're already doing for 10,000 hectares. Now, the organization that we're working with, Worldview International Foundation, has a charter from the Myanmar government for 100,000 hectares of mangrove restoration, and we've made an agreement for working on the first 10,000 of that. And so when we made that agreement, the founder of the NGO says, this is going to be a really great 10 to 15 year project, really great. And we said, well, let me tell you about that. We're going so fast right now that not even optimized, no swarms at all. It's 6 teams running 2 drones each. So you don't even have to run it in swarm technology. You don't have to be cost optimized. We can get that project done in 6 months, when they would typically spend 10 to 15 years working on that project. And so that's the power of this type of technology. It allows us to do things a lot faster at a lot larger scale. And then we hear a little pop, and it's going 2 per second right now. This is over mangrove in Myanmar. We did this. This is actually in a demonstration mangrove. We did this demonstration for Eric Solheim, who is the executive director of UNE. You'll see here the pilots. Their hands are on the controls, but they are not actually flying it. They're just there from a safety perspective to make sure that if the drones start to fly off where they're not supposed to fly off to, they'll take control. Drone is fully automated, and it followed that planting pattern, pre-programmed, launched itself, and landed itself. So this is fully automated technology. This is not the future. This is today. In December, that demonstration was in February. Our first run in Myanmar was in December, and you have two pictures here. And then the one on the left, you can see sort of in the center, just below the halfway point, there's a little white spot in there, and that is actually the seed pod planted from one of our drones. And then 3 months later, you can see that it actually grew into a healthy mangrove. We have short-term data only, so if your question is going to be, what are your long-term outcomes? Our first paid project was this time last year in Australia. So we don't have long-term data. All we have is short-term data for you, and this is one of the things that we're making sure that we're collecting in a way that makes sense, along with all the appropriate data to show what that looks like. In this project, we had a result of about 30%. In the laboratory, we had 60 to 70% germination rates. So you can see when we went out in the field, that dropped. And so we're trying to figure out why that dropped. And so we can try to optimize that. If you were to just grow those seeds, in a typical nursery pot, you would see about 60 to 70% germination. So with our pods in the laboratory, we're hitting roughly what you would expect to see in the nursery. When we moved it out into the field, there's other competing issues, and that could be competition with vegetation, it could be predation. We don't know exactly what the issue is what dropped it out, but you can see that there is definitely a drop from what you would see, what you would expect to see. So this is part of our challenge in our work moving forward. Now, in comparison, we had the local population do a typical planting run out there, restoration, on 2 hectares right next to the one that we planted, where they do direct seeding. They did 200,000 seed density on a hectare, and they came up with 0%, 0. And the reason for that is because if you don't plant the seeds in a mangrove in the mud, the tide comes in and washes everything away. And so this is one of the big challenges in mangroves in particular, and why our technology works quite well is because you can get it placed in that mud, and it's wet enough that the pod material breaks down very quickly, dissolves, and it leaves that already germinating seed, because the seeds were germinating literally when we were packing them into those pods, and they're ready to go from there. So those are really exciting results for us. They also asked us to do an agricultural demonstration. So this is a rice field, and we packed in rice into our pods, and we ran it out. Hearing is it running at 120 a minute to a second. You should start to see it hitting the ground right there. There you go. Now, the results of this were good. Everything grew the way we expected to. We don't have any percentage because we couldn't quite get it divided out. We had multiple seeds in a pod, so it's hard to figure out what the percentage efficiencies are. But we have an after picture, which I'm not going to show you, which shows nice green spots of rice growing. The difficulties is that we can't do a large enough field with the pods that we're carrying. So it's probably not the right application, but the fact is that it grew, and it's an interesting result, and it shows that there's probably going to be additional cross applications that we're not working on just yet, but that could be quite viable. In the case of mining restoration, which is really our go-to market, mining is in the rest of the extractive industries they're not tree planting companies. Their main core business is extraction of that mineral, and so they tend to pay higher values for planting trees in their area. They're paying about $10 a tree, which means there's a lot higher margin, and it's a good place for us to start because we're not at economies of scale yet. So think of it as our sort of Tesla moment, where Elon realized that it would cost him the same amount of money if he built a high-end roadster or a low-end entry market level car. But what he could do with the higher margins on the higher margin market, he could use those margins to optimize the technology, drive the cost down, and then allow that technology to enter into the lower cost market. So this is one of the big things that we're doing, is working with this industry as one of our go-to markets on a commercial basis, so that we can get to economies of scale, because we need economies of scale to really enter into the ecosystem restoration market in a way that makes sense and not force the restoration ecosystem market to pay for the technology development. Because the reality is that the margins are super thin on NGOs and the ecosystem restoration market, even in Canadian forestry, super thin margins, which means there's not money for innovation and development. So we go to the commercial side in order to do the development, but at the same time, we are working with organizations like, countries like Myanmar and other areas that are demonstrating how the technology can be rolled out across a variety of different sectors. So one of the more interesting things on this is that the mining company, in order for them to have compliance, they have to do effectively walk transects. So they lay out a line, they walk the transect, and they have a clipboard in their hand, and then they take a look at what species are on each side of the line, and then they sum that up, and then they make an assessment of, well, are we starting to meet our requirement for the restoration or not? Now, they're spending about $1 million a year per site. So the mine company that we're working with has 11 sites, which means they're spending about $11 million a year just doing the data collection and analysis. And so what they found is that we can come in and effectively in a day give them almost all the same data that they would get. You still have to do ground truth and transects, but not at the same level that you would typically do. And you get the full area as opposed to a transect. And we can reduce that cost effectively anywhere from 60 to 80%. And so this is the advantage, certainly, of drone technology on the data side, if you can figure out how to get those data analytics correct. BLM has the same sorts of issues. Canadian forestry, you walk a transect and you do that ecological assessment. Methods are pretty similar, but what you're looking for changes from country to country, and it's just a matter of trying to figure out, making sure that you're meeting those regulations. So in this one, so what you're seeing here at the Australian mine is the drone is flying along furrows, and it's planting into those furrows. So in this particular job, what happened was that field was completely flat the first day. The mining company came in and dug the furrows the first day. The second day, we went in and mapped, created the planting pattern, and then the third day, we went and planted. And so the mines do their restoration in two ways. On the main site, because they're on their environmental impact study, they have to take a look at the actual landform, which they have to reform to be what it was when they started. They do an ecology study, so they take a look at all the species that were there. And then they have about 30 species that they replant on the main mine site. Well, because they're taking off all the topsoil on the mine site during the operations and they're replacing it, the regulators assume that anything growing there is something that the mines actually planted actively. Whereas on the offset agreement, so they have a 10-to-1 offset agreement, which is quite cool. And what that means is that for every hectare that is mined, they have to restore 10 additional hectares off the mine site as a good neighbor policy. But the difference is that the regulators think that if there's not trees in straight rows, then the mines haven't actually done anything, and they've left it just to natural regeneration. And so the foresters in the room like going, really? The regulators think that? Well, actually, that's right. So they have to plant in straight lines, and so that's what they did. They set out furrows, we mapped it, and then we planted it that next day. Now, the interesting thing on this is this. With our planting pattern, we were able to hit within those furrows. It's an accuracy of about plus or minus 10 centimeters, but we had a 90% hit rate. And the objective for that, and I can show you what that looks like when you put it onto the map, is they wanted us to put down 3 pods at each specific location. Well, we fire one and we're too far along to get 2 more in. So what this meant is that we had to fly back and forth 3 times to each location. And you can see how tight those clusters are. And it's completely automated, no pilot, it's all automated. So this gives you an idea of how powerful the technology is becoming already. And again, it's only going to get better. So case study, Slave Lake and Canadian Forestry Service. So this is where I was last week. So a satellite image shows a lovely treed area. The reality is that they've already actually removed all those trees and harvested them. And so it looks like this. So the objectives of this one thing that's was really important to them was making sure that we identify the microsites for planting. So making sure that it has, let's see, it's this one. Selection criteria: bare soil, no debris, richer nutrient content, And then for us on the technology, it had to be within a flight window. So the drones are best when they're flying along a straight line. You don't want to hover and then go forward and stop and hover again and go forward, because the energy associated with that is too big. Your best thing is to keep them moving forward. So we picked microsites that were roughly within a flight line. These are 3-meter spacing, and that met those requirements. At the moment, we're mostly doing manual selection of those microsites. However, we collected enough data right now to take a look at those algorithms to just see whether or not we can start to automate that, because you cannot possibly select 2,500 per hectare by hand if you're going to be doing tens of thousands of hectares. It's just not reasonable. We planted white spruce and jack pine at a density of 2,500. And then when you roll it out to the 5-hectare site that we were planting, we had, the color is different people who were selecting those. It's not the different species. It's different people who are doing that. And so that's what it rolls out to look like. So once we automated that, then we were able to start planting into those microsites. And now, since this only happened last week, there is a lot of rain. We're expecting to see some early results in the next few weeks, is what the foresters are thinking that we should be able to see. So fingers crossed, we'll get some good results from that. Going into the mapping stuff, which is a lot of what you guys are interested in, certainly, is that we are using off-the-shelf technology, and one of the key platform that we're using is the SenseFly EB-Ag. So it has a low-cost multispectral sensor on it. It's 4-channel. It's mostly built for agricultural uses, and so those filter ranges are really specific to NDVI of specific crops. But the plus side is that it's pretty simple to use, so it passes the "I could teach my father how to use it" sort of test, where what you do is you download the satellite image of your area, then in the software you select the polygon of your specific field. Then the flight planning software will plan the map on where it's going to fly. You upload that map into the drone itself, and then to launch the drone, you just pick it up and you shake it. That spins the motor up, and then you just launch it by just throwing it out. It flies the pattern, collects the data, and then it does a belly landing on its own. So there's no pilot interaction, and then you just download the data from there, and then you can analyze it however you want. Lots of off-the-shelf software that can do some pretty basic, NDVI calculations and that sort of stuff. So, but it's really simple as a first go-to platform, which was where we started. We didn't want to invest a lot of R&D into developing more integrated platform, but the reality is that if we want to really do the right types of data sets, which includes digital elevation models, understanding topology, hydrology, we need to have a more integrated platform that includes the multispectral sensor, RGB, LiDAR, thermal, all as an integrated platform. You collect it all at once, and you don't do multiple runs with different platforms. So that's what we're working towards. And then in Myanmar, you can see our RGB data sets, and I'm just going to run through these. This is all stuff that you guys have seen. Using the Sentinel data overlay. Take a look at NDVI from ours. This is all regular stuff, but this helps us to do some of the initial calculations, and we can do classification, so we can take a look at the difference between the mangroves, the water, the grasses, and the dry lands. And so this is part of the overall assessment to determine how and where we're going to do the specific restoration activities. So our present capabilities are these. So we haven't done any of the above ground calculations. We are doing, like in Canada this time, we did take a lot of ground truth data on tree bowl size and height and density. So we're starting to collect the ground truth data sets to match up with the drone data sets that we have. So we're starting to roll that in. But certainly from a carbon perspective, we're not analyzing that yet, but this is one of the things that becomes really important for us over time. And it's not so much that we're involved directly in, say, carbon credits, but there are lots and lots of clients out there who are relying on carbon credits to enable their projects. And so the better able we are to model an area with how our technology is going to do the planting so that we can do some predictive data analytics on what we expect those outcomes to look like, are things that are going to enable clients and other people out there who are willing to pay for projects but want to have more confidence that they're going to get their return on their investment. So these are certainly things that we're keen on looking at, and then back to, the ecosystem modeling component, where that's not a deep strength of ours either. We can collect all the data we want, and we have our one data analytics guy who is a forestry specialist in remote sensing, so he's got some good skills. But we're one, and you guys can probably attest to how many people you really need to have on staff to do it at the level that we're talking about. We'll grow to that, but I think that there's a lot of opportunities in collaboration to start to leverage our technology and how it rolls out, but in a smarter way based off of data sets and data and analytics that organizations like yours already have. And it makes no sense for us to start that kind of skill set from scratch. It would make more sense for us to leverage what's already going on in the community. Just a few last slides, and then we can get into discussion. A few last slides are paying for trees. There are really big funds out there, and so one of the things I was suggesting earlier is that scale is really important, but scale is really important because one specific limitation on large-scale projects or rolling out these kinds of funds is this. A typical tree planting organization is going to have, a host of tree planters on their crews, and a really big one's going to have maybe a couple hundred planters, a really big one, which means their capability to run projects is really limited to $3 to $5 million a year worth of projects. Well, these organizations, when they're trying to mobilize $10 billion worth of capital, they cannot deal with that type of a project size. It's just not reasonable for them. They need project sizes that are in the hundreds of million dollars range for them to start to be able to justify the overhead associated with running projects. So they take a look at our technology as that enabling technology. So imagine if you still have that couple hundred planters and you set them up with drones, effectively they would be planting at 100 to 150 times faster than they're doing today, which means they can aggregate and scale up larger project sizes. That means it unlocks capital, which means they actually can do more work. And so this is, again, you need to think about how does the scale allow me to do my job, but how does that scale allow me to unlock financing and funding so that we can actually do the work as well. So that's the take-home message for that one. And then the other side is on the SDGs. So when you plant trees at the scale that we're talking about, you are restoring large enough areas that you start to do the biodiversity protection, expansion, soil nutrient cycles, the agricultural productivity, wealth creation. WRT and TNC, with the report what they put out in December of this year, they went back and took a look at what they believe to be the direct local economic benefits. And they're charting at $7 to $29, depending where you're at, for every dollar spent in restoration. So that's direct and indirect benefits. Everything from direct jobs in the planting work itself to the raw materials that you can create products and sell those to, like in mangroves at the bottom one, where the analysis in 2014 was $194,000 a year per hectare in ecosystem services. And that's because a healthy mangrove is producing a lot of nutrients that flows offshore, and that has a direct benefit to the local fisheries. And so you have that, as well as everything from protecting from just basic super tides is really important, not even counting tsunamis or anything much larger than that. So there's all these benefits, and it's important to think about how these impact, even if you can't capture the full value of that. And then finally, I would say that it takes a village of different organizations to be able to be effective at doing this. And so we've been very active in creating partnerships with organizations that have everything from on-the-ground relationships, because this is a relationship game, and we can't make all those relationships from scratch. We need to get people out there who already understand the local environments, they understand the local communities, they understand the local politics. And then get them to be that go-to project organization where we help them do that job at a faster rate, which has better outcomes and better impacts for the local populations while having a global benefit for everybody. So that is the end of the talk. So thank you for everybody for listening.
Thank you.
We have like 5 to 10 minutes. We will have the room here, so anyone who wants to stay can stay, but let's just keep it to 5 to 10 minutes for discussion, and then anyone can stay after that.
Cool. I'm gonna sit down so I can actually write stuff.
Doug?
Sure. Super interesting. and I love the applications that you identified so far. There's some high priority restoration sites and some high value ecosystems that demand, immediate attention in their life cycle. I guess the question for you, and you've hinted on this a couple times, is how quickly does BioCarbon engineering become a seed company? Because one of the major restrictions we've seen in the Brazilian Amazon and even landscapes like Puerto Rico, where we're doing work not on restoration specifically, but on the effects of disturbance from land use or storms on the extent of forest cover, is that there's nowhere near the seed capability on the diversity, particularly in tropical forests, to handle the restoration targets for any of the large-scale objectives you talked about, from the 2020 initiative up through the whatever version we're on for Sustainable Development Goals. 2,500 seeds per hectare, multiple species, hundreds of thousands of hectares. Nobody's got seeds like that. So how fast do you guys have to fill that niche to meet these longer-term goals? That's my question.
Great question, and the short answer is that we will never become a seed company. But you never say never, right? Remember, I don't know how to say no to anything. Look, I think, frankly, that especially in those sorts of areas, that community development is a super important component to what we're doing. You want to create land stewards that will become the owners of that area and want to protect it. So creating local seed collection companies and training them up so they do the collection, they do the storage, and then they work with us for seed pod assembly is, I think, a critical part of that. And so in Brazil, we're working with at least a couple of different organizations that want to do exactly that sort of work, everything from Pará to Acre to Mato Grosso. And so that has to be done. It would not necessarily be done within our company, but we would take a look at things like, let's see, the UK government is putting out a fund for Brazil right now, and seed supply is a key thing that they would be interested in having a local company built that's sustainable, that generates income. So that would be my answer to you in the longer run, is that we work with local governments and local organizations to create local companies that become suppliers to us, as opposed to us being the whole thing.
I just know that scaling is a time scale as well as a spatial scale. And so what I hear is a time scale of operations that is got a 5 to 10 year runtime on starting developing, expanding those capabilities. And you run out of seed stock in the meantime. That's why I guess I was pushing the point.
No, and I completely agree with you. Like in Myanmar, I think a good example of the difference is that in Myanmar there's about 25 or 28 species that are in the mix for the healthy biodiversity. Only about 11 of those species are compatible with our pods because of size. And so the point here would be is that it's really important to get establishment going, and it's better to get some species going sooner than necessarily worry about, am I going to do it perfect, and until I can do perfect, do I wait? And so I think establishment's really critical, getting that early establishment. And then like in mangroves, that's also critical to getting other species in there. So if you get establishment going, which means you start to protect that area, then you can go back and you can backfill it with additional biodiversity, additional species, because you've got an area now that is somewhat protected from tides and super tides at the very least.
We do have several questions online.
Okay.
Also, we have George Hurt online and Peter Griffith. George Hurt is the science team lead for the carbon monitoring system.
Yep.
So George, if you have any questions or comments.
Yeah, can you hear me?
Yes.
Okay. I'm getting some echo.
We hear you.
Okay. You still hear me?
Yes.
Yeah, lost you.
Yeah, go ahead, George.
Okay. So my question was about, first of all, thank you very much for that presentation. But my question was about forest succession and trying to understand where in sort of the forest succession sequence you're trying to seed these forests. So you're trying to seed them at an early stage of succession and community composition, or are you trying to seed them straight to some sort of old growth composition? That's my question.
Okay, great. Can we get another question online and add one or two? Yeah.
Peter. Peter,
You get that?
yes, Peter, can we get the other question? If you have any questions before he goes to answer.
Yes, I have actually sort of a similar question. Great minds think alike. I was thinking about it in terms of the, you were talking about working around the Yellowknife area in Northwest Territories. I believe you said that you were working in a log region. There's relatively little actual productive logging going on in Northwest Territories, and may have been kind of an experimental thing for them. There is, however, a huge amount of forest lost there to forest fires that largely are not controlled, and, unless they happen to be near some infrastructure. So my question was kind of like George's: are there any experiments going on in seeding the burned areas to attempt, for instance, to keep them in the spruce cover, as opposed to in some of the burned areas they're deviating, so to speak, to deciduous trees instead of the spruce that they quote unquote should be.
Okay, cool. All right, so let me start with forest succession. One of the interesting things that you can think about in terms of the use of the technology is that depending upon the objectives of the area and the quality of the environment, you can start to take a look at things like, if the soil is too degraded, you can seed in microorganisms that help start to rebuild the soil quality. You can put in grasses that start to rebuild that soil biomass. And when you start to improve that soil quality, you get to the point where you can start putting in successional species, and then you can do that over time. So that's the first part of it. And then the second part of it is that you can think about going in, and if you do an assessment on what the ecosystem is, if it was like, say, a degraded area in Brazil that's already, say, 10 years into its regrowth, but if you just leave it as it is, there was a paper that I read a couple of years ago, which I can never find again, and that's always the case in papers, isn't it? That showed that they compared an area in Brazil that had been left fallow over time, different areas. One was left fallow for 50 years, and they effectively said that they felt it took about 50 years to get to a natural biodiversity distribution if you just let it go 100% natural regeneration. But if you go in earlier and you put in pioneer species and then take a look at your successionals later on, you can actually get that return to a reasonably normal biodiversity to under 10 years. That wouldn't necessarily include Brazil nut trees or castanhas, which take 50 or 60 years before they even start producing. But you can definitely improve the succession rate by thinking smartly about what's there and what you can put in there. On the pioneer species, if you put in some fruiting species, then you start bringing in birds which poop out different types of seeds, and you can start to improve that biodiversity just sort of naturally by being really careful and clever about which ones you put in. Then on the Northwest Territories, we were in a place north of Edmonton called Slave Lake. That actually is an active lumber company that was harvesting in that specific area. And they were doing jack pine and white spruce as their crop. Your question on forest fires is a good one in the sense that we're not working on that yet. We'd certainly like to work on that. It's a little more limited funds typically from the governments that do the restoration post fires, and so we're working towards that. We have certainly our share of collaborators in Canadian Forestry Service that would like to see us move in that direction. And then one of the other key areas would be stabilization of topsoil. So if you got a fire coming and burn it out, can you lay down something that is going to protect that topsoil until you can get enough other trees or other species to stabilize it through longer term growth? And so again, different ways to think about how this technology could be used in a way that you just couldn't do the jobs previously.
Thank you. Sucho?
Just a quick one, the seed stock question. To have a seed stock, you need a viable ecosystem in existence. So I'm assuming it's going to be some other parts as opposed to the degraded part. It would be a very manual component to this type of project, I would imagine, is that correct?
Yeah, and so two sides to that. Well, actually, three sides to that. The first of which is that you go through and you decide which species you're going to put in. And if it's completely wiped out, are you going to put in natural species? Because we collect natural seeds, and the reason why we're really keen on collecting natural seeds is because the active gene sequences are environmentally specific. And so if you're not collecting seeds from the local region, you have the risk that your germination is not going to take in that area. So that's a really important factor to that. But if there are no seeds in the area, then you have to make some harder decisions about what you're going to select and what you're going to put in. Is it an appropriate species? Or is it a natural species? Or you can think about how do you select species that are appropriate for products that the local populations can harvest in an agroforestry sustainable way that can turn into an income source for them. And that is also a critical component to the selection of what species that you're going to select. Collection is an issue. So one thing that we're working on is certainly helping with large area mapping to identify where are the trees and the seed sources, so that at least you have a good map of where everything is, even if you can't get to them with drones just yet. But there are other organizations out there creating drones that will do seed harvesting. And then the other side to it is that we're working with at least one organization in Australia that has pretty good seed nurseries, specifically for, it's not necessarily growing up seedlings, but growing up seeds. And so they have a pretty sophisticated system working. And so we're looking at seeing about duplicating that in other countries where you would have a regional or local company that you would establish that would do just that large-scale seed production. I know it's, again, not core business to us, but critically.
Two more questions online.
Okay.
From Klaus Scott, might small-scale blimps support greater payload capacity? And also, if you could talk a little bit more about site preparation. What, if anything, is done for site preparation?
Yep, and then site preparation. So on small-scale blimps, it's a great idea, and we're considering small-scale blimps for really kind of like the last-mile delivery component, where you don't have easy access roads, but you could use small-scale blimps to deliver the drones or deliver the seeds and deliver everything else that you need. Even with small-scale blimps, it's hard to get those into forested areas and protect that against the elements. So the drones actually provide us more flexibility in terms of access to steep slope sides. So like helicopters, even you think that they can hover, but you can't actually put them too close to steep hill slopes. So they're going to be up above effectively the jet stream, the aerodynamics coming over the hill. You got to protect that helicopter asset and the people in it. The drones on the plus side don't have anybody in it, so that means you have that health and human safety issue goes away, and you can bring it a lot closer to the place that you want to actually do the real work. So helicopters, I think, not helicopters, drones, I think, give us the most flexibility. The biggest limit I think you identified, which is how much mass can you carry, and this is where swarm technologies help. If you're looking at direct seeding, this is where our other systems are going to be interesting, where we can have 150 kilos of payload mass that still provide us the flexibility and reduces the human health safety issues.
And about site preparation?
Oh, site preparation, right. So we don't do site preparation directly ourselves. So that is going to be clients that we work with. So like in Canada, they did the site preparation. In Australia, they did the site preparation. In Myanmar, the local population clears off all of the dead wood that they use for charcoal. So they're effectively doing the site preparation for us, but not necessarily because it's site preparation for a project. It's because that's what they're using for their cook fires. As the result, we have a cleared area that makes it a lot easier to do the planting. It's not something that will be core to us, so we take a look at Like say, for instance, in Malaysia with a pulp and paper company that we're talking to, they're clearing out their stock, and then what they leave behind is a lot of debris and small areas that you can get in between, but it's steep hillsides. We've shown that with the accuracy that we have right now that we can get to those microsites even in the debris. And so the expectation is that as long as the soil is soft enough so that we can actually get the seeds penetrated. Now let me remind you, we don't need to dig holes. So depending on the seed diameter, that's how deep you have to plant. So if you have something like an acacia, which is a very small seed, you're talking surface planting, so you don't need to get down very deep. If you're looking at like an acorn, 3 or 4 centimeters is all you need to get into. So we don't have to plant very deep, so that's not really a hard requirement for us. It's not necessary. So as long as we can get around the debris and get to the actual soil surfaces, then we don't need to do any additional site preparation. And then if you have to go to an area where you really need to have the site preparation, well, think about where you're at. What is the type of environment? What is the topology? Can you actually get equipment there? Do you have to put people on the ground to do the site preparation? And if you do, imagine having to clear off a steep hillside of hectares by hand, and it's just not viable. It's not tenable. But if your project is forestry or lumber, pulp and paper, where you have a real economic driver, then you put money into doing that. If you're looking at ecosystem restoration, where you want to have, say, assisted natural regeneration, you want to get the biodiversity going, you want to get things established, you want to get them growing, but you're not so worried about getting to a 90% yield, then our technology is going to fit into that pretty well. Again, this is a tool, and you use our tool when it's the right tool for the right job, and if it's not the right job or the right tool for that job, okay, that's great. But it will be the right tool for a lot of jobs, and you just have to think about it carefully.
So, that's it. Thank you, everyone. For
Okay,
staying
great.
on here, and thank you to Lauren.
Thank
and
you.
Thank you.
And thank you all for listening. I appreciate it.